In January 2003, two prestigious astronomers presented some new findings to the American Astronomical Society that would seem to indicate that large spiral galaxies grow by gobbling up smaller satellite galaxies. Their evidence, a faint trail of stars in the nearby Andromeda galaxy that are thought to be a vast trail of debris left over from an ancient merger of Andromeda with another smaller galaxy. This process, known as galactic cannibalism, is a process whereby a large galaxy, through tidal gravitational interactions with a companion galaxy, merges with that companion, resulting in a larger galaxy. Galactic cannibalism, therefore, is a common phenomenon that occurs in the universe. The most common result of the gravitational merger between two or more galaxies is an irregular galaxy, but elliptical galaxies may also result. It has been suggested that galactic cannibalism is currently occurring between the Milky Way and the large and small Magellanic Clouds. Streams of gravitationally attracted hydrogen arcing from these dwarf galaxies to the Milky Way is taken as evidence for this theory. Like life on Earth, galaxies can indeed eat each other and evolve over time. The Milky Way's neighbor, Andromeda, is currently dining in on one of its satellites. More than a dozen star clusters are scattered throughout Andromeda, the cosmic remains of past meals. The image is from a simulation of Andromeda and our galaxy colliding, an event that is likely to take place in about 3 billion years. Several examples of this have been observed with the help of the Hubble telescope, which include the Whirlpool galaxy, the Mice galaxies, and the Antennae galaxies, all of which appear to be in one phase or another of merging and cannibalizing. However, this process is not to be confused with galactic collision, which is a similar process where galaxies collide but retain much of their original shape. In these cases, a smaller degree of momentum or a considerable discrepancy in the size of the two galaxies is responsible. In the former case, the galaxies cease moving after merging because they have no more momentum to spare. But in the latter, the larger galaxy's shape overtakes the smaller one, and there appears to be little in the way of change. Astronomers have detected what they believe to be one of the earliest instances of galactic cannibalism in an ultra-faint dwarf galaxy called Tucana 2. The findings stem from the discovery of an ancient dark matter halo located in a galaxy about 163000 light-years away from Earth. Tucana 2 is just one of dozens of dwarf galaxies surrounding the Milky Way. They are thought to be artifacts left over from the first galaxies in the universe, and Tucana 2 is among the most primitive of them. Galactic cannibalism occurs constantly in today's universe, according to MIT News, but mergers in the early universe are not so certain. Tucana 2 will eventually be eaten by the Milky Way, no mercy, said by one of the astronomers. And it turns out that this ancient galaxy may have its own cannibalistic history. The team hopes to use their approach to discover even older and more distant stars in other ultra-faint dwarf galaxies. As interesting as all of these finds are, they don't exactly bode well for those of us who call the Milky Way galaxy, or any other galaxy for that matter, home. Given our proximity to the Andromeda galaxy and its size, the largest galaxy of the local group boasting over 1 trillion stars to our measly 500 billion, it is likely that our galaxy will someday collide with it. Given the sheer scale of the tidal gravitational forces involved, this process could prove disastrous for any and all life forms and planets that are currently occupying it. Relevant to this is another phenomenon called galaxy harassment, which is a type of interaction between a low luminosity galaxy and a brighter one that takes place within rich galaxy clusters such as Virgo and Coma, where galaxies are moving at high relative speeds and suffering frequent encounters with other systems of the cluster by the high galactic density of the latter. According to the computer simulations, the interactions convert the affected galaxy disks into disturbed barred spiral galaxies and produce starbursts, followed by, if more encounters occur, loss of angular momentum and heating up of their gas. The result could be the conversion of late type luminosity spiral galaxies into dwarf spheroidals and other dwarf ellipticals. So interesting, right? Stay tuned for more cool and incredible space stuff.